this is going to be non-calculator. We're going to evaluate each of these expressions. Now remember that an exponent stands for, a logarithm is trying to solve for that exponent. So we can imagine a little question mark there. And unfortunately, 9 to what exponent is 72 is not something that is easy to do. Not at all. It's not on your powers chart. So the best thing that we can do in this situation is maybe we could use our log laws, combine it to a single log, and then see what happens. So if I was combining this to a single log, the first thing I would do is move that 3 in as an exponent. That'll give me 6 cubed. Because only if it's 1 log minus 1 log can I use the log law of dividing. And I get log base 9 of 6 cubed divided by 72. Now you have a couple of options here for simplifying this. You could actually multiply 6 cubed out and get 216 and have 216 over 72 and put that in lowest terms. I recommend, though, that if you factor, like 6 cubed is 6 times 6 times 6, and 72 is 36, which is 6 times 6 times 2, that makes life so much easier if you can factor it and simplify. And then we're just left with 6 over 2, which gives us log base 9 of 3. Okay? You have two options from this section. Option 1 is you look at this and know the answer, so write the answer down. If you look at it and you don't know the answer, right? Because this is asking 9 to what exponent is 3? If you see the answer, you can just write the answer right away. If not, then I would suggest introducing and saying, let x equal log base 9 of 3. Change it to exponential form, so the base is 9, the exponent is x, the answer is 3. And are those on your same powers chart column? Yes. Can you change them to the same base? Yes. I could change the 9 to 3 squared. This is 3 to the 1. So I have 3 to the 2x equals 3 to the 1. So 2x is equal to 1. And the answer is 1/2. Now when I go back up here, now that you see the answer, remember an exponent of 1/2 is a square root. Does it make sense that the square root of 9 would be 3? So you could have just seen that and written 1/2, but sometimes, right, this happens to all of us, sometimes we just don't see an answer right away. So then you could go to that method of changing it to exponential form and getting the same bases to solve it. And it worked out the same. So you get 1/2 either way. Is there a part B? Yes. Get ready for a loud camera sound. Is everybody done A? Everybody good? Same thing in B. I look initially and I'm like, 4 to what exponent is 12? I can't do that in my head. 4 to what exponent is 3? Can't do that in my head. So maybe it makes sense to combine this as a single logarithm. Start by putting in the exponents. All the bases of those logs are the same, so we can use our log laws. And we would do this all at once. Whatever is added, so the 6 squared and the 12 will be in your numerator. Whatever is subtracted, which is the 3 cubed, would be in the denominator. And then we have to simplify this. So I was simplifying this 3 cubed. I wouldn't write 27. I would just leave it as 3 times 3 times 3. 6 squared is 3 times 2 times 3 times 2, and 12 is 3 times 4. There's a 12, there's a 6, there's a 6. And this is nice because now my 3's will, right, 3 divided by 3 is 1. So I can simplify all of that. And I'm left with log base 4. 2 times 2 is 4 times 4 is 16. Can you do this one in your head? 4 to what exponent would be 16? 2. Right, so we don't even have to do the let x in this situation because we can just see the answer and write it down. All right, questions? For practice on this one, number 13.